Welcome to Section 3 of our course, Designing for Multiple Devices. In this section, we are going to be looking at a few ways that we can design our UI for different types of devices, including responsive design with the anchoring system, the canvas scaler, and changing build targets in the build settings. We'll also take a look at the video player component that was introduced in Unity version 5.6, and we'll see how we can use it to display a cutscene or a transition between scenes. Our first video will be responsive design. We're going to be taking a look at how we can create responsive layouts for our UI. So first off, we'll need a canvas to experiment with. Go to the Create menu and select UI Canvas. You might notice that we have a canvas scaler component on the created canvas object. This can be used to control how the canvas will scale with the width and the height of the screen as it changes. To illustrate this, create an image on our canvas. Leaving the canvas scaler scale mode as constant pixel size, try resizing the game window and see how the image will stay in the same place regardless of how we scale the window. This is because the image is positioned relatively to the center of the canvas. We can choose different aspect ratios to fit the screen to from this drop down here, and the image will still stay in the same distance from the center. We've used the anchoring system before in Unity. However, we've mostly been working to a specific screen size and positioning and sizing our elements based on this. The responsive way to place images is to use the anchoring system's stretch mode. If we drop down the anchor presets, we can see on the right and the bottom that we have blue arrows indicating this will stretch an element across the width or height, or both. Let's choose the top option and set the pivot and position by holding Alt and Shift. This will stretch the image across the full width in the top, the middle, the bottom, the full screen, the right, left, or center vertically. We can use a combination of these anchoring presets to make our UI design dynamic and responsive. I'm going to add a shadow component to make this a little easier to see. And now that we have our image spread across the top, we can set the height using a pixel value. This will then have the same height no matter the vertical scale of our canvas. But we can also set the anchor to be a percentage of the screen. If we drop down the anchors property on our rect transform, we have a min and a max value for the x-axis and the y-axis of the canvas. By setting these to values between 0 and 1, we can make our UI elements dynamically scale to that percentage. In this case, the min and the max of the y value have been set to 1, meaning they'll both be anchored to the top of the screen. If we change the y min value to 0 and reset our pixel offsets in the rect transform, we can see that the image will stretch from 0 to 1 in the x-axis and from 0 to 1 in the y-axis across the canvas. If we wanted the image to take up top 30% of the screen, we could set the min value to 0.7 and reset the bottom offset to see that this will scale to 30% of the screen size no matter the size of the actual screen. We can get the image to anchor to the bottom by setting the anchors to 0 and 0.3, taking up the bottom 30% of the screen, and this will keep the scale when we change the screen size as well. Of course, this also works with the x values. If we set the min and the max to 0.25 and 0.75 respectively, our image will always take up half of our screen and be centered. Keep in mind that we have to reset the offset values on the rect transform whenever we change the anchors. If we set the y values to the same, we can have an image that will be centered in the y-axis as well. This is a blank image, so it looks fine no matter how we stretch it. But what about something like a text element? If we add a text element and set it as a child of the image, we can set the exact same values as the image's rect transform, making it stretch across the top of our image box. And we can also use the anchors to give this a padding as a percentage. If we set the x min and max to 0.01 and 0.99 respectively, we'll have a 1% padding on either side of our text when we scale it. We can do the same with our height, but in this case we're anchored to the top, so we'll set both of our values to 0.99. If we wanted it to be a specific percentage in height, we can change the min value to something like 0.89. And now our text element will stay at 10% of the height of the image. but it won't update in size. The font size itself will stay the same without scaling unless we choose the best fit option on the text component. This will allow us to set a maximum and minimum size for our text, and the canvas will scale it up to match the width or height of its rectransform bounds. We can see this in action by setting the minimum Y value on the rectransform to something higher, like 0.79. When we scale our window, the text height and width will scale along with their container. So that's one way we can scale the elements of our canvas responsively. One downside of this is that we have to set responsive anchoring up for each of our elements in our canvas, which is fine if a little time consuming. Another way to scale the whole canvas with our window is to use the Scale with Screen Size option on the Canvas Scaler component. This will let us choose a reference width and height for our canvas in pixels and automatically scale the canvas up and down to match the width or height of our reference size. This option tries to match the width by default, but you can decide the mix of the values by changing the slider. To use both the width and the height equally, set it to 0.5, or 0 for width, just width, and 1 for just height. This is mainly useful if you know the general dimensions of your canvas. For example, if we were to create a UI that fit on an iPhone, and we wanted to use the same canvas on an Android device that has the same aspect ratio, this would handle the scaling between the two resolutions. Another setting that we could use is the Constant Physical Size Scale mode on the Canvas Scaler. This lets us create an image that is specific measurements in real-world units, such as inches, centimeters, and millimeters. In this case, 1 unit on the rectransform scale corresponds to 1 inch. We can change the physical unit option to use centimeters, millimeters, inches, or points, and set the DPI or dots per inch option to get different screen pixel densities. One example of this is that the iOS Retina screen has a DPI of around 300. This setting is mainly useful if you need to have an image be a specific size in the real world, say to match a physical object that the user scans, or if you wanted to measure something specifically. An important thing to note is that this doesn't mean we can't also use our responsive anchoring system with these scaling types. They work best when used together, and each UI will have different needs. And that's it for responsive design in Unity. We looked at using the anchoring system to make elements remain the same size when we scale the window, as well as the Canvas Scaler component, and how we can use that to control the scale of our UI.